We are going to go ahead and jump into Law of Science Day 2, which is going to focus on the assignment. Again, I cannot stress to you guys enough that you should be focusing on the agenda that I send out to you because it will not match Edgenuity. So things will be off by a day or two. That is okay. I want you to follow the pace that I set because as I've gone through the semester, again, things don't line up or there's a lot on one day. It does not mean that you don't some days have days that are going to be a lot more overwhelming. When that happens, I usually try to put your worst day on the Monday. So you kind of have the week to work it out if you need to, or if you want to jump start it over the weekend and maybe get one assignment done so you don't have so much throughout the week, feel free to do that. But also I will send out you guys' agendas, post them in Google Classroom on Friday so that you can go ahead and you can see that information of what your week's going to look like. Is it a heavy week or is it a light week? Some weeks are worse than others, and it's just the way it is. I don't have full control over how Edgenuity sets it up, so I try to make sure the tests are around the same time, and obviously we need to finish the course at this appropriate time. In regards to the course, your end course date is going to be May 24th. It is a Monday. Some of you guys are like, wow, that's really early because we don't get out till June 4th. I have a lot of seniors. Senior grades are due before then. Senior finals are usually that Monday and Tuesday of the week prior to their graduation. And so it's really important that the course is done for them. So it is set up that way. Okay, now I'm back on track in regards to our lesson for the day. So sorry about that. And let's rock and roll. So we talked about Law of Science yesterday. We did some examples. It was a long lesson. Today's won't be as bad. Tomorrow I have a little bit more just because it's the quiz and there were some good questions. I like to go over them. But what's today's going to look like? So it says, use the triangle shown on the right to answer the questions. And it says, which equation can you use to solve for A? Well, remember how I said I like to do my setup where I like to go ahead and I like to create my table of information. So I have my angle A, B, C, my side A, my side B, and my side C. So if I look here, if this is angle A, across from it would be my side A. This is my angle C, so across from it's my side C. And of course, this is my side B because it's across from my angle B. So what information do I know? Well, I know A is 35 degrees. I know C is 85 degrees. I don't know my angle B, but we can easily find that, right? And I also know that this side is 30. I don't know A or C. Okay, so here's the problem. Use the law of science, I have to have a full set. And when I write it down right now, I don't have a full set. But remember, if I have two angles, I can easily figure out what that third angle is. So if I want to solve for angle B, then I could go ahead and add my 35 plus my 85, which is going to give me 120. And then I go ahead and subtract my 120 from 80, which of course is going to be my 60 degrees. So this measurement is 60 degrees. If that's the case, then I now have a full set. And again, what I mean by a full set, it's an angle with the corresponding side. So I can use my law of sines. My law of sines says that my side B, which is 30, all over sine of angle B, oops, sorry, my 60 degrees, let me fill it in. So this is my side B, this is my angle B, would be equal to, so it says that I want to solve for A. I want to solve for A. So if I want to solve for A, then I would want to set it equal to my side A all over sine of my angle A, which is 35. So see the correlation, that's always going to be the case. If you guys have any questions, again, feel free to unmute yourself or go ahead and just put it in the chat, whatever works best for you. So for this one, it says, which equation can we use? So I look to see which one matches. And if I look here, I could see it's going to be the second one right here. Done. Go to the next problem. All right. So this one says, complete the steps to determine how many triangles ABC can It can't exist with the given measures. So we talked about this yesterday, and we had the equation that H is equal to B sine of A. And for some of you guys, it's really hard. If I don't have B and my sine of A, like how do I know which one is what? How do I correlate it? Well, if this angle is an A, then it's going to match with the angle here. So this would be my A. Then the corresponding side, this would be my little a. So if I wanted to, I could just relabel those C's as my A's. And that's perfectly fine. And if I do that, then it's easy to plug in and visualize what those actual values are. So it says, what is the approximate height of the triangle? When we talk about the height of the triangle, we're talking about from the top straight down, so that this would be kind of a little bit of an angle there. So that's perpendicular. The height is going to be perpendicular to that base. It's also called an altitude sometimes. So it's from the point perpendicular to the side. That would be the height. So how do I figure out what that is in this case? I plug in my B is going to be 18.7 times my sine of my 35 degrees. And then I would go to my wonderful calculator and I would plug it in. So quickly I'll show you. Make sure you are in degrees. Make sure it's in degrees. And so when I look here, I end up with, let's see if that helps, 18.7 times my sine of 35 degrees. Kind of hard to see. That's better in the light right there. And I'm going to get approximately 10.7. Make sure you watch your rounding. So H is approximately 10.7. So how many triangles exist? Well, if you remember from yesterday, we had a bunch of different scenarios. So I would keep that handy as you guys are going through the lesson. And I'll go ahead and I'll quickly show you guys from yesterday. We had, these are going to be my scenarios. This is going to tell me how many triangles I have. So I want to compare my A and my H. So A, which we marked as my A, is going to be my 16.1. My H is 10.7. So A is greater than H. If that's the case, I look over here. A, well, we know it's not going to be no triangles. It's not going to be right triangles. They're not equal. So it's going to be one of these two. So A is greater than H is going to be one of these two. Now I need to look at my A and my B value. So A was my 16.1. The B was 18.7. So I have A is less than B. So A is less than B. That means that if this is going to have two triangles. So we know we're going to have two triangles. We don't have to solve it out. They didn't ask for us to solve it out. They just want to know how many triangles is it going to have. Okay, I'm going to go ahead and flip. All right, my next example. Here we go. So they give us this picture. And it says if the distance from Bermuda to San Juan is 954 miles, so from Bermuda to San Juan is 954 miles, what is the distance from San Juan to Miami? This is what we're looking for. This is my unknown side. Okay, so how do I go about this? Well, again, I like to have my triangles labeled and I like to be able to create my diagram of information. So I'm just going to call this triangle A, B, C. If that's the case, then this is my side A, this is my side B, and this would be my side C. So when I fill in my table of info, I can see what do I have and what am I looking for? So I know my angle A is 52.7 degrees. I know my angle B is 65.1 degrees. I know my side A is 954 miles. My side B is what we're looking for. And I don't know either of these two. Although if I needed to, I can easily find this angle C. Okay. So I'm looking for this side B, and luckily I already have the angle. So I can use my law of sines. I know right away from looking at this, I can use my law of sines because I have a full set. Later on this week, we're going to be learning about law of cosines, which is not going to be the same. If I have a full set, it's law of sines. If I don't, then I'm going to want to use my law of cosines. So here's how I go about this. I go ahead, it's going to be my side A, my 954 over my sine of my angle A, which is 52.7, is equal to my side B, which is what I'm looking for, over my sine of my angle B. So again, this is going to be my A over my angle A. This was my side B over my angle B. And I can solve this. And the way that I solve this is I use cross multiplication. If I have two ratios that are equal to each other, two fractions that are equal to each other, then I can cross multiply them. So this is going to be equal to x times sine of 52.7 is going to equal my 954 times my sine of 65.1. Solving for x, I'm going to divide both sides by sine of 52.7. Sine of 52.7. I could go ahead and cancel these off, and I have that x is going to be approximately, I go to my wonderful calculator and type it in, and it's going to be 1087.8, which is going to be my 1088 miles. So they give you multiple choice, so that will help you what place do you guys round it to. In this case, it was the whole number, and it also said to the nearest mile here. So it's going to be 1088 done. Again, questions, I go too fast, you're not sure on something, make sure, just let me know, ask me. And my last problem for the day, it says, as an observer found the measure of the angle from the ground to the top of the building from two different locations. So they found it from here and from here, so they're moving around. What is the measure of angle A? So I look here, I go, okay, well, this is 42, then how do I figure this piece out? Well, these angles are what we call supplementary. Supplementary. So if they're supplementary, that means they have to add to 180. So if I want my angle A, it's going to be 180. Oops, I was thinking 42 there. So 180 minus my 42, which is going to be 138 degrees. So this angle here is 130 degrees. Easy peasy, right? Okay, well, what if I want to find this angle up here now? Well, now I know two angles in my triangle, so I can easily find my third angle. So if I want to figure out what angle B is, then I add my two known angles, my 35 plus my 138, and I end up with 173, and I subtract that from my 180, and I get that my angle B is going to be 7 degrees. So then my question to you is, can I figure out my side C? So I'm going to add to this. What is side C? That's this piece right here, along this piece right here. So what about if I want that side right there? So if I notice, this side is part of two different triangles. It's part of this triangle, and it's also part of this triangle. How do I know which triangle I want to use? Well, if I look at this one here, I know this side right here, and I know all my angles, and I'm looking for that missing side. However, here, I know my angles, but I don't know any of my sides. And so that's going to be a problem, because remember, of law of sines, I have to know one of the sides so I can get a full set. So I can't use that idea. So I'm going to want to focus on this triangle right here. And with that triangle, again, I'm going to do my setup, my A, my B, my C, my side A, my side B, and my C. So this side is across, this 10 meters is across from my angle B. So that's telling me that my side B is 10 meters. My angle B, we already said, is 7. My angle A was 138. We found that. And my angle C was already given. We want to figure out this side right here. That's what we're looking for, is this side right here. So I look and I realize I have a full set, so I can use my law of sines, and I want to find the side C. Okay, well, let's look at this. So it's going to be 10 all over sine of 7 is equal to my side C all over sine of 35. So again, this is going to be my B over my angle B, my side C over my sine of angle C. And then I would cross multiply. So you can notice that the patterns, it happens over and over again. We're doing the same process over and over again for these. So I end up with 10 sine of 35 is equal to C sine of 7. I probably should have written it over here, but that's okay. Divide both sides by sine of 7. So I get C is approximately, I plug all of this into my calculator. If you're having calculator problems, let me know. Follow along so that you can practice, so that you know how to work the calculator. So it's going to be 10 sine of 35 equals divided by sine of 7. If you're not getting the right answer, make sure you're doing the correct order of operations. That's usually why I do equals in between for you guys, is because some of you guys don't end the parentheses. This whole piece would have to be in a parentheses as well if you're going to divide it all in one shot. So it just depends how you decide to use it. The other big mistake is, again, that your calculator might be in radians and not degrees. So we get that this is going to be 47 meters. So this is 47 meters. But let me ask you one more question just to add to this problem. You want to add to this problem. What if I said, what is the height of the building? What is the height of the building? So what if I want to know, what is this height right here? What is this piece? How can I solve that? Well, some of you guys are like, oh, you just use your law of sines. But wait a second. If I look here, now that I know this side right here, and I have a right triangle, what could I use? We can just use our SOHCAHTOA. Sometimes we forget about our basics. We get so caught up in the new concept that we forget about our basics, that this is just a right triangle. And I can go ahead and I could just solve this using my SOHCAHTOA. What does this mean? Well, if I know this angle, this side is my opposite, and I know my hypotenuse, so I'm looking for the opposite. I know my hypotenuse, so I would use my sine. And this is telling me then that sine of 42 degrees is equal to my opposite side, which is that height, all over the hypotenuse, which is my 47. And I can easily solve this then by multiplying both sides by 47. So my height is going to equal 47 times sine of 42 degrees. I plug it in my calculator, and it's going to be approximately 31 meters. So you can find a bunch of different pieces within this problem. So we found the missing angles, we found our side C, we found the height of the building. Of course, I could find this distance from the building. So I could use SOHCAHTOA. In this case, if I was looking for my adjacent side and I had my hypotenuse, that would have been a cosine. So there's many things that you guys can do. I wanted to emphasize this piece right here because there are some problems. I think there's some on the quiz as well that has something similar to this. And you are given a right triangle. So if you have a right triangle, you want to use your SOHCAHTOA. So just as a reminder. If you guys have any other questions, feel free to reach out to me at any time today. Remind is the best way to get a hold of me. And otherwise, I will go over problems from your quiz tomorrow. You guys have a fabulous day.
Have a good day.
Thanks, Rob. Take care.
You too.